Hello class, and welcome to Introduction to Calculus 1. Now today I will just be going over the first of two of the core ideas of calculus, and that is the derivative or differential calculus. The second core idea of calculus is the integral, and we will be moving into integrals in the next unit. But first, I think it is beneficial to understand the derivative and what the derivative actually means. So, to start off, I'll be taking you back to year 9. So, in year 9, you would have learnt the idea of a linear function. Now, you would have been given a set of axes, you would have been given a line, and you may have, for example, been given 2 points on that line. So let's say this is point P, and this is point Q. Now, this point P would have had an x value. So let's just call this x value 2. And Q would have an x value. Let's call that value 6. And P would also have a y value. Let's call that 1. And Q would have had a y value. Let's call that 3. Now, a teacher would have asked you something like, here's a set of axes, here are 2 points on a line, and here are the coordinates of those 2 points. And she would have said, or he, find me the gradient of line PQ. Now, the gradient means the slope. So how much it increases, how much y increases as x increases by a certain value. Now, you may remember, to work this out, it's just the rise over run formula, which equals the change in y over the change in x. So that little triangle just means the change in. So let's go back over to our set of axes. We have this p coordinate. So the x coordinate of p is 2, and the y is 1. As you can see here, x, y. Likewise, at q, we have 6 and 3. 6 and 3. Now, to find out the gradient or the slope of this line, we need to find the difference in y divided by the difference in x. Now, to find the difference between two numbers, it goes a little something like this. So we have the first number, so we have, to find the difference between two numbers, you basically just take the smaller number away from the larger number, right? So a formula to get that is y2 minus y1 divided by x2 minus x1. So that's the difference in y over the difference in x. Now all we have to do to find the gradient of this line is to plug our coordinates into this. So we have y2. Well, actually, first let's give them their coordinates. So that's x1, y1, x2, y2. So it would be y2, which is 3, minus y1, which is 1. So 3 minus 1 over x2, so 6, minus x1, so 2. And that answer is 2 over 4, which is equal to a half. So this is now the gradient. So gradient is usually denoted with m equals half. And what this means is, as x, so as this value increases by 1, so as x increases by 1, y will increase by half. So y will go up in increments of half. Right, so that's a throwback to year 9 and what a linear equation is. But in the real world, equations aren't always in straight lines. For example, you could have trigonometric functions that have a line that is curvy like this. Or to show you a more simpler example, you could have a curve that looks like this. Now this is what x squared would look like. Right, so you can see that this isn't a straight line, meaning at different points along this curve, the rate at which it increases is going to change. So for example, let's pick this point here. Now, a line going through this point would touch it and touch no other point on the line. So this is what you call a tangent line. Okay, but if we were to pick another point along this curve, which curves, the tangent line would look a little different. Because remember, it's only touching this point and no other point along the graph. So you can see as you move along this curve, the slope changes. And what the derivative does, is it finds the rate, sorry, not even the rate, the instantaneous rate of change at a certain point. So that is the first of 2 core ideas of calculus. The derivative. What is the instantaneous rate of change at a point on a curve?